Okay, moving on, in Chapter 8, we will be studying special right triangles. So remember, this whole entire unit is about right triangles. And you might be asking yourself, well, what makes these so special? Well, let's begin. The first right triangle is special because it's coming from the idea of having a square. So right here is our square. We know in a square that all four angles are right angles. And we also know that all four sides are the same measure. That's what defines a square. So if we took that square and we split it in half, then what kind of special right triangle would we have? Well, you can see again that these two legs are the same measure, and here's my right triangle. So if the two legs are the same measure, then we can call this special triangle an isosceles right triangle. Yeah? So these two legs are the same, so it's an isosceles triangle. It's also a 90-degree angle right here in the corner, so it's an isosceles right triangle. Now, in that isosceles right triangle, what happens when we draw this diagonal? What happens to the 90-degree angle? Well, remember, in this special case of a square, that angle would be bisected by the diagonal. So therefore, each of these degree measures would be 45 degrees. So another way we would name this particular special triangle would be calling it a 45, 45, 90 degree right triangle. So this is referring to the degrees. A 45 degree, 45 degree, 90 degree triangle, which also means isosceles right. It's the same thing. Now something unique happens when you have an isosceles right triangle. So let's see what that is. It says, so remember this is going to be true for all isosceles right triangles because they're all going to have a 45, 45, 90 degree triangle. Despite how big their sides are, they're all going to be similar because of AA, which means this is going to hold true for every single isosceles right triangle that exists. Okay, so it says start with a length of 1 for the side of the square, which is the leg. So going up here, we're going to call x equal 1. And we call it x. Then using the Pythagorean theorem, find h. So h is my hypotenuse, right? So we need to write our answer as a simplified radical. Now remember, this hasn't been required. However, to see the relationship, I'm going to go ahead and do that because it's going to be easier to fill in the theorem down here later. So if I have a side length of 1, here's my isosceles right triangle. This is 1 and this is 1. I'm trying to find h. That means I'm going to take the length of one side and square it, so that's 1 squared. I'm going to take the length of this other side and square it, and that sum should equal the hypotenuse squared. So 1 squared is 1, 1 squared is 1, so 1 plus 1 is 2, so 2 equals the hypotenuse squared. Therefore, what do we do to both sides? We take the square root. Therefore, the hypotenuse is equal to the square root of 2. So that would be the square root of 2. Okay, well let's try another one. What if I made each side length a 2? What would my hypotenuse be? So I would do 2 squared plus 2 squared equals hypotenuse squared, right? The length of the side squared plus the length of the side squared. This is using the Pythagorean theorem. So that's 4 plus 4, which is 8. So 8 equals the hypotenuse squared. What do? We take the square root of both sides. So h equals the square root of 8. Well, if we took the square root of 8 on the side and we actually went back to your Algebra 1 skills and simplified it, we would break that down to a perfect square and a non-perfect square. 4 times 2 equals 8, so therefore the square root of 4 times the square root of 2 equals square root of 8. But the square root of 4, that's a perfect square, so that becomes 2. So h is also equal to 2 root 2. Okay, let's try another one. How about a length of 3? 3 squared plus 3 squared equals h squared. Again, if I draw my isosceles right triangle, these sides would be 3. How do we find h? Well, 9 plus 9 is 18. So 18 equals hypotenuse squared. Take the square root of both sides. So therefore, h equals the square root of 18. Well, a little side note, the square root of 18 is the square root of 9 times the square root of 2, and 9 is a perfect square, so that becomes 3 root 2. Okay, so are you noticing anything? Here we started with the side length of 1, a leg length of 1. And we got, for our hypotenuse, root 2. Here we started with a leg length of 2, and we got for our hypotenuse 2 root 2. Here we started with a leg length of 3, and we got for our hypotenuse 3 root 2. So let's try one more, even though you might be picking up on the pattern. Let's try 5. 5 squared plus 5 squared equals hypotenuse squared. Well, that's 25 plus 25, which is 50. 50 equals the hypotenuse squared. Take the square root of both sides. The hypotenuse equals the square root of 50. But the square root of 50 is the square root of 25 times the square root of 2. Well, what is the square root of 25? It's 5. As you might have predicted, it was 5 root 2. So recording that here, we got 1 root 2, we got 2 root 2, we got 3 root 2, we got 5 root 2. So what do you think it's going to be for 4? Hopefully you're saying to yourself, that would be 4 root 2 for the hypotenuse. So therefore, no matter what length your leg is, if it's x, let's call it, how will you find the hypotenuse? You would take that leg length of x and multiply it by the square root of 2. So can you see a pattern? I hope you did. I just told you the pattern. The pattern is, in an isosceles right triangle, the hypotenuse is root 2 times as long as the leg. So again, if we do here, and we say this is 11 and this is 11, my hypotenuse will be 11 root 2. If I go do something like this, and I say, if this is 23 root 2, what are my 2 legs? Well, hopefully you're saying that's 23 and 23. Okay, but let's do the practice problems you see down here. Okay, so letter A, can't see it very well on my thing. So we have, this is a 90-degree angle, this is 72. It says that these are the same, therefore this is going to be 72. So therefore, what's A going to be? Well, it's going to be the length of the leg times root 2, because it's an isosceles right triangle. Okay, let's look at letter B. So my right triangle is somewhere in here like that. So if my hypotenuse is 13 root 2, what is each leg going to be? Well, you can go backwards, right? If this is, that means each leg is just 13. So B equals 13. Okay, how about letter C? C is a little bit trickier. So if this is letter C, then that means this is also letter C, which means 10 equals the leg length times root 2, right? Remember, in a right triangle, if this is x and this is x, then my hypotenuse length is x root 2. So if each leg is C, then the hypotenuse length is C root 2. So I don't want to know that 10 is C root 2 necessarily, but I do want to solve for C, and this helps me solve for C. How? Well, I can divide each side by root 2. So therefore, what does C equal? C equals 10 divided by root 2. And that's it. So go back and say, well, remember you took the length of the leg is 10 divided by root 2, and if we multiply it by root 2, we should get the hypotenuse. Well, that's true, because if I cancel these, I get 10, and that's my hypotenuse. So this theorem right here still holds true. So therefore, I know I did that process correctly. So if you're given the hypotenuse, and it doesn't have a radical in it, we'll just set it equal to C root 2, or the leg root 2, divide by root 2, and that's your solution. All right, let's check out another special case triangle. The other special triangle is related to the equilateral triangle. So what do you know about an equilateral triangle? Hopefully you're saying to yourself, I know an equilateral triangle has all side lengths the same. So this is the same. And I know that each angle is 60 degrees. Well, if I take and draw an altitude in an equilateral triangle, then what happens to my two angles up here? They get bisected or split in half. So now I have the second special triangle, which is a 30, 60, 90 degree triangle. So we call this a 30, 60, 90 degree triangle. The measure of angle CAD is 30 degrees. Why? Because the altitude bisected it, bisected CAB. The measure of angle CDA is 90 degrees, and the measure of angle ACD is 60 degrees. So there we have it. It's a 30, 60, 90 degree triangle. Again, all equilateral triangles are similar to each other. And then if we put an altitude in there, that means all 30, 60, 90 degree triangles are similar to each other. So whatever we discover now is going to hold true for any 30, 60, 90 degree triangle. It will always work. Okay, so in order to figure out the relationship this time, we need to give lengths of the sides of the right triangle. But notice here, I started with side length CD. So this is 30 degrees, this is 60 degrees, and I'm saying side length CD, according to this information, is equal to 1. Well, then that also means DB has to equal 1, right? Because this altitude split that triangle, that base, in half. So if this is 1, that means this side is equal to 1, which means AC and AB are both equal to how much? Well, that's 1 plus 1, which is 2. So this entire length is equal to 2. So this is equal to 2, and AB is equal to 2. So right away, how does the hypotenuse compare to the shorter leg? Okay, why are we calling 1 the shorter leg? Well, hopefully you're going back to the last unit, which said it's opposite the smallest angle. 30 degrees is the smallest angle in that triangle. Therefore, CD is the shortest leg. AC is the hypotenuse, and we know that is the longest side. So how does the hypotenuse compare? Well, how does 1 compare to 2? It looks like, to me, it's twice as long. It is twice as long. So how does it compare? It's twice as long. So the hypotenuse is twice as long as the shorter leg. So if the shorter leg is 1, the hypotenuse is 2. If the shorter leg is 2, the hypotenuse is 4. If the shorter leg is 3, the hypotenuse is 6, right? Because this would be 3, 3, which means the whole length is 6. This is 8, 10. What am I going to write in general here? I have to do twice whatever the original leg was. So that's 2x. Okay, how do I find the relationship? So this is a pattern. It's always going to be true for a 30, 60, 90 degree triangle. The hypotenuse is twice the length of the shorter leg, or the shorter leg is half the length of the hypotenuse. Right? The hypotenuse is 4, the shorter leg is 2. The hypotenuse is 8, the shorter leg is 4. Okay, but what's the relationship with the longer leg? So that's what we need to figure out, and we're going to figure that out using the Pythagorean theorem. Okay, so if the short leg is 1, that means we're going to have 1 squared plus the other leg squared equals the hypotenuse squared. Well, that's 1 plus x squared equals 4. I subtract 1 from both sides. I get x squared equals 3. I take the square root of both sides. Therefore, the longer leg is root 3. Okay, let's try the same thing with the short leg being 2. That means 2 squared plus x squared, right, I'm on this column now. 2 squared plus x squared equals 4 squared, based on the Pythagorean theorem. Right, here I go. I have a 30 degree angle, 60 degree angle, so we don't know this. We know this is 2, therefore this is 4. So I get 4 plus x squared equals 16. Therefore, x squared equals 12. I take the square root of both sides. That's the square root of 12. But the square root of 12 simplifies to 2 root 3. Oh, does this look familiar as a little pattern we're getting? Okay, what do you think is going to happen to the third one? We have 3 squared plus x squared equals 6